The student is asked to find 95% confidence interval for the proportion of students who take notes using data from a random sample of 87 students. Which of the following is a correct interpretation of the interval 0.13 to 0.26? So notice the P in the middle. This represents the population proportion. And notice that the symbol for this is different than the symbol for the sample proportion. The sample proportion will usually have a little caret hat on top of it or some other kind of mark that differentiates it from the population proportion. So one of the first things we learned in statistics is that there's a difference between a population parameter and I misspoke. Difference between a population parameter and a sample statistic. Sample statistics are taken from a sample while the population parameters are taken from the entire population. So there will be a difference in notation. So you might see a little star or something like that if it's for the sample, but if it's just a regular P with no other notation on it, that means it's for the proportion. And that's key in choosing the correct answers here. So let's go through and see how many of these would be correct. And we'll talk about why each one seems like it's not right or is right. So the first one says there is a 95% chance that the proportion of the population is between 0.13 and 0.26. Now that matches up with the confidence level here on our confidence interval. So there is a 95% chance. That's correct to say because when the interval was constructed, we used a percentage probability of 0.95 when extending from our population proportion estimate, which is called the sample proportion. We use the sample proportion as a point of estimation, and then we stretch the net out using 95% confidence. So that answer seems right. The next one says the proportion of all students who take notes is between 0.13 and 0.26 95% of the time. Now, that almost sounds right, but it's it's uh it's not really the correct way to interpret this. We've used a probability to figure out how far to the left and the right of the sample proportion we should go to find an interval of estimation for the true population proportion. But that doesn't mean that we know 95% of the time that's what's going to happen. It just means that we've made this estimate with 95% confidence that the true population proportion does fall within that range. So I'm going to skip over that one. The third one here, with 95% confidence, a randomly selected student takes notes in a proportion of their classes that is between 0.13 and 0.26. Okay, a randomly selected student takes notes in this proportion of their classes. That doesn't sound right because what we were reading in this introduction is that we were doing a confidence interval estimate for the proportion of students who take notes, not what percentage of classes students take notes in. Okay, so not looking at each student and saying what percentage does that student, how many of their classes basically are they taking notes in. No, it was do they take notes in general in all of their classes and what proportion of a whole set of students are saying yes to that question. So that one is also not correct. Um, the fourth one here, there is a 95% chance that the proportion of note takers in a sample of 87 students will be between 0.13 and 0.26. Now that option sounds very similar to the one up here that I selected, right? So let's try to identify what's the difference between these two. There is a 95% chance. This one also says there is a 95% chance, right? Keep reading that the proportion of, okay, now here's where it changes. The difference is this one says the population of the population, the proportion of the population, and down here this says the proportion of note takers in a sample of 87. Now, because they're specifying that we're in this statement, specifying that it's only within a specific sample of 87 makes this the incorrect answer. Because again, if you're talking about within just a sample, then you're talking about the sample proportion, and we're not estimating a sample proportion. We're estimating the population proportion of all students in that population, whatever population it is. It could be all students in the United States that you're considering to be your population. It could be all students in a certain college or in all of the statistics classes in a certain college. I mean, all that can be specified, but the whatever the population has been identified as, we mean all of them. When we're doing an estimation, we're estimating for the entire population. But we're using sample statistics to make that estimation, but the estimation is in fact for estimating the population value. So that one's no good. And finally, with 95% confidence, the proportion of all students who take notes is between 0.13 and 0.26. All right, now I kind of like that one too. Let me read this again. With 95% confidence, the proportion of all students who take notes is between 0.13 and 0.26. Okay. Hmm. There's a very fine line between this one and this one. So I'm going to read the top one again and compare it to the bottom one. There is a 95% chance that the proportion of all, that the proportion of the population is between, okay, and here with 95% confidence, the proportion of all students who take notes is between 0.13 and 0.26. Well, it was specified that we're talking about the proportion of students, so I guess that could be considered different than just saying the population, because maybe you mean all the people in the US, or maybe you're just narrowing it down to students only in the US, for instance. So this one's more specific and it matches the statement up here. So you can really tell what the answer should be by reading when it says we did a confidence interval for, well, what was it done for? It was done for the proportion of students who take notes, right? So we want to find the answer that matches that the most closely, right? So I think that's the best answer. Yay, I did it. All right, so that's the end of that question.